taking what we've been doing and applying it to probability. So back in Algebra 1, or maybe even before Algebra 1, you guys should have talked about probability. For example, simple probability like I have a bag full of M&Ms, 10 are red, 5 are blue, 6 are green. I stick my hand in the bag. What's the probability I pull out a green M&M? Okay? So that's kind of just simple probability. When you learned probability, what you should have learned is that probability, oops, what happened to, let me pull those back up because that's going to drive me nuts. Got to quit opening those before I'm ready. Okay, so probability, what you should have learned about probability back in Algebra 1 is that the, yes ma'am, thank you. We're good. Okay, that you should have learned that the probability, any probability that you've talked about so far, is the number of outcomes in your event. So in our case, that may be the number of green M&Ms.
So basically, if you just get hurt during the day, call that.
For me.
Just
Man.
contact your phone or anywhere you're looking for.
All right, that's exciting. I'm not going to put that on my phone. Yeah. If this is workplace OSHA, if I get hurt, this is what I can call and get help. I don't know. Okay. So probability is the number of outcomes in your event, so like the number of green M&Ms, over the total number of outcomes that are in the entire sample space. So all the M&Ms total. Okay, that's kind of just basic probability. Or a real general way of saying is what you want out of the total. Okay? So in geometry, we're going to be looking at different types of probability based on our geometry ideas. So those will be things like, so definition for geometric probability is the probability of an event based on a ratio of geometric measurements like length or area. And since we've been talking about calculating area, we're going to find the probability of areas. So first of all, with our answers, when we're talking about probability, what is the lowest probability you can have? 0. And what's the highest probability? Okay, so we can talk about it in terms of percent, a 0% to 100%. Or if we left it in fraction or decimal form, that's 0 to what? Not 100. 1. Okay, so on your homework, you're going to be giving me two different answers. You're going to either give me the decimal or fraction form, which would be answers from 0 to 1, or you're going to give me the percentage, which would be that decimal or fraction changed to a percentage, okay? So that would be a number between 0 and 100. If you get a negative, you've done something wrong. If you get something over 1 or over 100, you've done something wrong. You can't have more than 100% probability of something occurring, okay? So what we're going to do is we're going to look at the concepts of length and area and figure out what's the probability. So something like I throw a dart at a dartboard. If I have a circular dartboard, I'm talking about area. So what's the probability that I hit the bullseye? I would need the area of the bullseye compared to the total area, okay? So this is kind of the idea. So first thing we're going to look at is probability based on length. If we're looking at length, it may be something like, what's the probability that you pick a point on this line segment, AD, but the point is actually on line segment BC? So what we want is the probability of BC. So we would get the distance from B to C on the top, and we would have the total distance of AD on the bottom. So it's what you want over the total, okay? So the sample space is all the points on AD, the event is BC, and so this is how that would look with one exception. I'm going to try to get you ready for Algebra 2, and in Algebra 2 we'll talk about probability again. When we do, you need to put what kind of event you have in parentheses. So that's why I wrote probability of BC, because that's what we're talking about, that points are on BC. You could leave it actually off since we're talking distance, and that would be fine. Okay, the other thing we're going to talk about, I'm going to skip over here to area first. If I, like I said, were to throw a dart at this little board and I want to know what's the probability that it lands in the blue triangle, then I would want the probability of the blue triangle over the entire rectangle, right? So it would be the area of the triangle divided by the area of the rectangle. Question?
Basically, like in last class, it might be like you have a circle and a triangle and subtracting.
Right, so now you're doing a division situation. And so again, if you're writing it, you would write probability of, and it would be the triangle would be what you're looking for there. Okay? The other thing we're going to talk about is in terms of a circle. We have not learned how to find the area of this blue shaded region yet. We're going to learn that coming up. Yes, sir?
There was a question.
Yeah, it was like hard and I could skip it.
Okay.
That was on there, and there was like 3 of them. I had to watch it for.
Okay. It didn't require you to know the area of this. That was the loon problem, right?
Yeah.
Okay, so you were supposed to find the area of the things you could find and subtract away the pieces to find the part you needed. Okay, you can ask me about it tomorrow when we have review day if you want me to go over it though. But we will learn not next chapter, but chapter 12, how to find the area of that what's called a sector. This is called a sector here, but you don't need that. All you would need if you're dealing with the circle is the concept of how many degrees are in a circle. 360. So all you would have to compare here is angle measure. So if, for example, they told you this was 30 degrees, then you know that the fraction of the circle that you have is 30 degrees out of 360. So you can find the probability of this blue region by just doing the angle measure out of 360. Your answer should always be in simplified form, a fraction or decimal between 0 and 1, or a percentage between 0 and 100%. Okay? All right, so these are the 3 big ideas for 10-6. It's going to be pretty simple, other than the pictures can get a little bit harder when you're doing your calculations. You may have to find, for example, on this problem, if they wanted to know the probability of the white area, you may have to find the probability of the whole, subtract away the probability, or excuse me, subtract away the area of the blue to find the area of the white. Does that make sense? Because we don't have a formula for just that white part. So you may have to do some harder problems where you're finding the whole minus the part, and that's just what goes on the top. And then you still divide by the entire area. Okay, so probability should be a number between 0 and 1, or 0% and 100%. Okay, the other thing is they may ask you what's the probability of an event not occurring. So if there's a 20% chance of rain, how much percent is there not of rain? 80%, right? So it's just 1 minus the probability that it will rain. So if you are trying to find the probability of something not occurring, it might be easier to find the probability that it does occur and then just subtract that from 1 or from 100%, depending on what your answer's in. Does that make sense? Okay. All right, so then we're just going to do a few examples. I may skip some of them because some of these get pretty easy. So again, when you're writing your answers, the way I want to see it is the probability of, and then whatever your event is. So in this one is that it's on RS. So we would say the probability of RS equals, careful. So what is RS? So it should be 5 out of, and then what's the total? 25. I won't count off either way. It's fine. In this case. So then you'll simplify that. Do not leave it as 5 over 25, and your answer will be 1/5. Probability doesn't have units. Probability is only a percent of an event occurring. There are no units. It'll be the same units on both top and bottom, so they should cancel. Okay? All right, when you write your answers though, you need to make sure that you are leaving them in simplified form. So 1/5 is fine. You could also put 0.2. You could also put 20%. But make sure that you have your answer simplified and don't round unless it tells you to. Okay? Excuse me? So 1/5 is okay, yes. You need to be able to change 5/25 though to 1/5 without a calculator because that's coming up in Algebra 2 again and we won't have a calculator for a while. So make sure you can take 5 into both. And then if you want to change it to a decimal, you could either just say, what do I multiply 5 by to get 10? So you can say that that's 2/10, which is 0.2. Or you could do 5 into 1 and start dividing. Okay, or just 1 divided by 5 on your calculator since you have a calculator. Okay, and then multiply by 100. All right, what about probability that it's not on QR? Not QR. Think about it with me. Look at your picture. Probability not on QR. Say it again, Elena. One more time. Not 1 minus 13. Where did 1 come from? So if you're thinking, I want to do 1 minus the probability, then you have to find the probability. 13 is not your probability. Remember, probability is a number between 0 and 1. Excuse me? So you could do it as 1 minus the probability that it would occur. So the probability that it will occur would be 1 minus 13 over 25, which is 12 over 25. And will that reduce? Nope. So that's our answer. Or you could have just said if it's not on QR, then it is on what parts? PQ or RS. So you could have just added 5 and 7, the parts that were not QR, which are 12 over 25. Okay, so that's totally fine too. I mean, yes. So using that idea, probability that it is on PQ or QR. So when you see that word or, you're adding those together. So what would we have if it's on PQ or QR? So PQ or QR would mean the 7 and the 13. So 7 plus 13 over 25. Or if you wanted to, you could think about them as separate probabilities. 7 25ths plus 13 25ths. But when you see that word or, think add. So that's going to give us 20 25ths, which reduces to 4/5. So make sure you do simplify. Is this making sense so far? On the last one, because it said not QR. So when you see that word not, if you go back a little bit in your notes, we said that when it says not, that is 1 minus the probability that it will. Yes, and that would give you the remaining pieces of 12. Yes. But you still have to divide that by the total. Okay. All right, so if you look at the next one, this one's just kind of a little bit different probability. It's really not distance or area or angle measure, but it's getting that idea of what you want out of the total. So pedestrian signal at a crosswalk has the following cycle: walk for 45 seconds, don't walk for 70 seconds. The question is, what's the probability that the signal will show walk? Again, make sure when you write your answer that you put probability of walk equals. Good. So it would be 45, which is what you want. What's the probability that it says walk? And how many total seconds is it flashing? 115. 70 plus 45 or 115. And then simplify. For sure, 5 will go into both because it ends in a 5. So 9 over 23, and that does not simplify, so that is your answer. And again, if it said to round to the nearest percentage or whatever, you would type it into your calculator and round. Okay, let's move on to a different concept. Any questions on distance? Okay, this is the same exact thing, except it's just greens, yellows, and reds, so I'm not going to work it. It's the same thing, though. It's just a line segment. Okay? So then come see me in Encore. All right, so let's look at the spinner. Spinner is the same idea, but now we're dealing with angle measure. So what's the probability that it lands on yellow? Again, your answer should be probability of yellow equals. And then now we're dealing with angle measure. So if the yellow sector is 140 degrees, then we're going to divide that by the total circle, which is 360. Ends in a 0, so it has to reduce at least by 10. So 14 over 36, but it can go further. What, Edwin? 7 over 18. Good. And that would be our answer. Easy? Okay. This is just a blue or red again, and what did we say we do when it says or? Add, so I'm going to skip that. Same thing we just talked about. Let's do this one, which says not on green. We'll do another not problem. So what's the probability that it is not green?
1 minus 1.
Careful. You were close, but I think what you said was not. There you go. So it would be 1 minus the probability that it is on green, if you want to work it that way, which would be 1 minus, what's the probability it is on green? 108 over 360. Or you could just say it's everything except the green. So all the other ones added together, what's 60 plus 140 plus 52? 252. So it's 252 over 360. And then reduce. It's even on both top and bottom, so it has to simplify by 2. Maybe some more than that. What does it reduce to? So I'm going to show you something with your calculators that I don't see any of you doing, and we've talked about this once already. If you take 252 and divide it by 360, and it gives you that decimal, first of all, if it's 0.7 exactly, you automatically should know the fraction. What is 0.7 as a fraction? 7 out of 10, right? That's 7/10. But you could also go to math, and number 1 changes it back to a fraction in lowest terms. And when you do that, it says 7/10. Okay? So, but if it's 0.7,
Oh wait, I didn't divide.
okay. Yes, you have to hit enter first. Okay, any questions on that one? Any questions on your calculator? All right. So the next one's where they get a little harder, and this is the end of 10.5. You'll see 3 different blanks. I'm not going to work all 3 different problems, but I gave you 3 spots in case we needed to. This one is where we're dealing with area. So it says find the probability that a point chosen randomly inside the rectangle is in each shape. Round to the nearest hundredth. So first of all, notice it does say to round to the nearest hundredth, so make sure you do that. It says find the probability that it's in each shape, and so I broke it up. The first one you see is the probability that it lands in the circle. The next one, bottom left, says that it's in the trapezoid, and then bottom right says probability that it's in one of the 2 squares. Okay? So we'll work 2 of those. I think we need to do one of the 2 squares to make sure you understand that terminology. And then you guys pick. You want circle or trapezoid? Okay. So you do what the directions said, which said round to the nearest hundredth. Always follow your directions. Okay, so probability that it's in the circle. So if we're dealing with area, what do we need to calculate for the top of our fraction? Area of the circle. What's going to be the bottom part of our fraction? The area of the entire rectangle. Make sure that you divide to get your final probability. Excuse me? What do you mean? Sure. Yes, you sure can. Okay, so let's calculate the area of the circle first. What's our formula? Pi r squared. What's the radius in the circle? 9. Good. If the diameter is 18, the radius must be 9. What is 9 squared? So our area is 81 pi. Leave it as 81 pi. This is not your answer. Do not type it in and round it. You only round at the very end of your problem. Okay, so up here we're going to have 81 pi in the numerator. Then find the area of the rectangle. What's the formula for area of a rectangle? Base times height. What are the base and height? 50 times 28. What's 50 times 28? 1,400. The great thing about these multi-step problems where there's more than one part is that once you've calculated the total area for part A, you have that total area then for part B and C and D, so you don't have to do it again, okay? Then you're just calculating the new part for the numerator. Okay, now you're going to type that in on your calculator. Be very careful that when you do that, you're doing 81 times pi and then dividing that by 1,400. Round it to the nearest hundredth according to the directions. Nearest hundredth. 0.18. Okay, so 0.18. Remember that this is a decimal answer, so it's just 0.18. Or if you wanted to change that to a percentage, what would it be? 18% multiplied by 100. Okay, so look at the number that's on your calculator. Somebody carry it out a little further for me.
18176.
Okay, I'm going to stop you right there. That's good enough. So if the directions had said round to the nearest tenth of a percent, highly likely you're going to have questions on your homework and your test that say things like that. Round to the nearest tenth of a percent. You first have to change it to a percentage, then you round. So if I want to change this to a percentage, what do I do? Multiply by 100. So I move that decimal 2 places to the right, then I round. So this would be 18 point what? Okay, but nearest tenth of a percent. So it would be 18.2%. Does everybody understand how to round according to those directions? Okay. Not with pi, because pi is irrational. Pi goes on forever. There is no way to write it as a fraction. So if you ever have pi in a number, it will not change back to a fraction. That's why the directions now say to the nearest hundredth. Okay? Any questions on probability so far here? Okay. The last one we have there I want us to do is the probability that it's in one of the two squares. So think about that. We're saying if we were to throw a dart at this board, what's the probability that the dart lands in one of those two squares? Very good. You need to find the area of both squares, right? Because if the dart could land in either one, then you need both total areas as possibilities. Does that make sense? Okay, because even though it says one of the two squares, you still add them both together because it could land in either one. So what do we notice about those two squares? Okay, they're squares, so they're definitely equilateral, but what do you notice about them when you compare them to each other? They're congruent. They're the same. So you really just have to find the area of one of them. So let's find the area of the square. What's the formula? S squared. And our side length is? And 10 squared is? 100. But we have two of them. So times 2. So what's going in the numerator here? 200. Okay, and we already know what goes in the denominator because we found the area of the whole thing already. What was it? 1,400. So then we can simplify, and what does that become? 1 over 7. But it did say round to the nearest hundredth. So even though this is equal to exactly 1 over 7, go ahead and type it in and follow your directions. 0.14, everybody agree? So we would put 0.14, and that's our answer to the nearest hundredth. But again, if the directions say round to the nearest hundredth, we'll put 0.14. Okay? But follow your directions on the homework. If they don't say to round, try to leave it in fraction form. There will be some, though, that may not say round, but you're dealing with something like pi. So simplify it as much as you can, or maybe you want to type it in and go ahead and round and give me both answers. But follow the directions, because I'm going to grade it based off whatever the directions say. Okay? Any questions on 10.6? Okay, I thought that this would flow well with what we've been doing and do it first. 10.5 is a little different, so let's head to 10.5. Okay, so 10.5 is going to ask you to figure out what happens to the perimeter or the area when you change dimensions. So it's asking you to describe the effect of the change. So for example, if I have a triangle and I change only the base by multiplying it by 2, what does that do to the perimeter? What does that do to the area? If I have a square which has the same length on its base and height, and I change the base, what does that do to the perimeter or the area? That's what they're asking here. So we're going to look at a couple of ways you can work the problem. So one way we're going to do it is by the long method, which would be to actually calculate the original perimeter or area, and then do the change to the shape, calculate the new perimeter or area, and figure out what happened. How many times bigger did it get, or how many times smaller did it get? And then we're going to look at the formula and see if we could see that without having to actually calculate all of it. And then we're going to try to summarize and see if we can come up with some generalized rules that would be shortcuts we could use that would save us time. Okay, so bear with me because we're going to do it a couple of different ways. And stop me if you have questions. But the big idea is you're going to have to write a sentence that explains what happens to the perimeter, what happens to the area. Ignore all that. Here's our first example. Okay, so describe the effect of each change on the area. This time we're just focused on area. We have what shape? Triangle. And the effect that we're going to change is the height of the triangle will be multiplied by 6. Okay, sorry, so that's missing on yours. Would you add that sentence to your paper? The height of the triangle is multiplied by 6. So we're going to talk long method first. Worst case scenario, this is what you could do if they give you information, but I want to warn you, there will be at least one problem, either on the homework or the test, where you don't have enough information to work it the long way. So you're going to try to eventually be able to understand these shortcuts, okay? Long method though, here we go. We will just calculate the area of the triangle to start with. So what's our formula? 1/2 base times height. What's the base of the original triangle? 12. What's the height? 5. So what is half of 12 times 5? 30. So we get 30 square inches for the area of the original triangle, right? Everybody should be okay with that. That's a simple little problem. Now we're going to change it and have a new triangle, and we're going to multiply only the height by 6. So what does that make our new height? 30 inches. So now we're going to recalculate the area of the new triangle. It's still 1/2 base times height. The base didn't change. It's still 12. And now the height is 30. What's half of 12? 6. And 6 times 30? 180. So we get 180 square inches. When you write your answers, you are not going to say things like it increased by 150 square inches. You're going to tell me how many times bigger or how many times smaller. So here's how you can calculate that when it's not simple to see. It's always going to be the area of the new divided by the area of the old or the original. Okay? Or perimeter of the new divided by the perimeter of the original. Kind of like we're dealing with dilations and scale factors, and it's always the image over the pre-image. Well, the new one over the old one. Okay, so we would take 180 and divide it by 30, and how many times do we get? 6. So your answer would be, when it says describe the effect of each change, the area is 6 times greater. So write me a complete sentence, starting with a capital letter, ending with a period, and describe what happens to the area. If I could spell area. The area is 6 times greater. Does that make sense? Okay, now let's look at the formula and see if you could have seen that from the formula. So this is the long method. Shortcut would have been just to do it to the formula. So if I have 1/2 base times height, and I multiply just the height by 6. So where I had h, I'm now going to put 6h. Compare that to the original formula, which was 1/2 base times height. And do you see that in that formula, all we're doing to the 1/2 times the base times the height is multiplying the formula by 6. So if you compare the two formulas, you can see that this is just going to be 6 times more. And then maybe you'll see it when we do the next one where it isn't exactly the same as the number we put in. But do you sort of see that right now? Okay, if you don't, long method is your goal as of this moment. Hopefully by the end, though, you'll start seeing it. Okay, that's the first one. Get in your mind, all we did was change one dimension, right? By multiplying it by 6. And what effect did it have on the area? Same effect, right? We multiplied one dimension by 6 and the area was multiplied by 6. Keep that in your mind because we're going to try to make a generalized rule here at the end. Okay, go to the next one. So this is one where we'll have to graph it first. So grab a sheet of graph paper. So I'll give you some time to catch up with me. Graph RSTU. I know. Going quick. You shouldn't need distance formula here. Right. You can think about it just using Pythagorean theorem. Same idea. You just have to be able to see that right triangle, whereas distance formula you could technically do without graphing it if you just have your coordinates. Okay, everybody with me? Got it graphed? All right, so the directions don't really say exactly everything they should say because it's back to the same directions as the problem before, which said, describe the effect of the change on the area if, and then here's the direction, the diagonal SU of the kite with the vertices, blah, 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 is multiplied by 1/3. So what's being multiplied by 1/3? Read it again. What's being multiplied by 1/3? The diagonal SU only, okay, is being multiplied by 1/3. Okay, so how many dimensions are we multiplying here? One. One dimension. How many dimensions did we multiply last time? 1. We multiplied just the height by 6, and the area was also multiplied by 6. So if we multiply just one diagonal here by 1/3, what do you think it's going to have on the area? What impact? Okay, it's going to shrink it. It's going to be how many times smaller? 1/3. We think. Let's see. So again, long method. Long method would be to find the area of the kite originally. What's our formula? 1/2 D1 times D2. This is good practice for our test anyway. What's the length of diagonal RT? RT. RT is 4. Okay, so we have 1/2 times 4. What's the length of diagonal US? Okay, so what is half of 4 times 9? 18. So we have 18 square units for the original kite. Now we're going to go and find the area of the new kite, which is going to be 1/2 diagonal 1 times diagonal 2, but this time we're going to take that US and we're going to multiply it by how much? 1/3. So what was the length from U to S again? 9. And so if we take 1/3 times 9, what is our new US? 3. Okay, so the first diagonal we're not changing, it is still 4, but the second diagonal is now 3. Is everybody following what we're doing? Okay, what's half of 4 again? Times 3. So now our new area is 6. Remember when you divide to see what is the effect, how many times bigger, how many times smaller, you take new and divide it by the old, the original. So it should be 6 divided by 18. Otherwise, if you do it the wrong direction, it's going to look like it got bigger, but it didn't get bigger, it got smaller. So what is 6 over 18? 1/3. So we would say the area is multiplied by 1/3 because it was 1/3 of the original. You could say that it is, let me make sure that my brain is following your brain. It is 1/3 of the original size, so yes, it is 3 times smaller. Yes, you could say that. Are we good with this right here? Okay, could you have seen that from just looking at the formula? If the original formula, why do I do that every time? If the original formula was 1/2 D1 times D2, and you're just taking one diagonal and multiplying that one diagonal times 1/3, do you see that that just multiplies the entire area by 1/3? Okay, and if you don't, then you need to do it the long way. Okay? And eventually we're going to see a shortcut that you can know for every single time. Yes, ma'am.
On the triangle one.
Mm-hmm. Mm-hmm.
And on this one, it was 1/3, and that was like, triangle, it was 6 times greater. I like how to, like,
It was 180 divided by 30.
oh yeah.
Okay, which is, does that make sense? Okay. That's why you're always doing the new divided by the old. Sorry, now it's slowing down. Okay, is this where we're at? Okay, this changes. So I need everybody focus with me. The first two examples, we only found the change on what? Area. And how many dimensions did we change? 1. Okay, keep in mind, that's what happened. All right, so next one, we're going to describe the effect of the change on the perimeter or circumference. Those are the same thing, it's just one's depending on whether it's a polygon versus a circle. And we're going to see what happens to the area. So we're going to look at two different situations here. What happens to the perimeter or circumference and what happens to the area if this is what occurs. So the base and height of a rectangle with a base of 4 feet and a height of 5 feet are both doubled. So the base and the height are now both going to be doubled. And what does it mean to double? Times 2. So again, I'll start out doing the long method and we'll see if we can see some shortcuts. So we'll start with our original rectangle, which has a base of 4 feet and a height of 5 feet. And we're talking about two separate situations here. So let's start with just perimeter and see what happens with the perimeter. So with the perimeter, what's the formula for a rectangle? 2 base, careful, plus 2 height. Okay, what's my base length? 4. So I have 2 times 4 plus 2 times 5. So that gives me 8 plus 10. So what's my perimeter? 18. Okay, now we're going to do the new shape. So the new shape is going to have a doubled base and a doubled height. So what is that going to make the new base? 8, and the new height? 10. So the perimeter of the new shape will be 2 times 8 plus 2 times 10, which should be 16 plus 20, which is 36. And then how do we divide? What over what? Always the new one divided by the old one. So it should be the perimeter of the new over the perimeter of the old, which is 36 over 18. So how many times bigger did it get? Twice as big. So the answer would be the perimeter is multiplied by 2. Or you could say the perimeter is doubled. Safe way to say it is what it is multiplied by. So the perimeter is multiplied by 2. Questions on perimeter? Okay, could you have seen that in the formula? So if I looked at the formula and I took this perimeter and I said, all right, I'm going to multiply, I wrote that wrong. This is 2 times 2 base plus 2 times 2 height. So that now this is 4 base plus 4 height. If you look at the original perimeter formula and the new perimeter formula, do you see that it is just 2 times bigger? Okay, so if you can see it in the formula, then you don't have to write all of this stuff down. Okay, let's talk area real quick. So I'm going to come back over here and deal with area. Area is what formula? Base times height. So what are we going to get for our area on the original one? 20. 4 times 5 is 20 feet squared. Come over here to the new one. 8 times 10 is 80 feet squared. So what are we going to divide? Area of new, area of old. What do we get? 80 over 20, which is 4 times bigger. So we would say the area is multiplied by 4. Or we could say that it is quadrupled, okay? Doubled is by 2, tripled is by 3, quadrupled is by 4. I don't know. Okay, could you have seen it from the formula? So again, compare the formula here. It was originally base times height. We doubled the base, so that's 2b. We doubled the height, that's 2h. And if we simplify that, that's 4bh. Do you see that it's 4 times bigger? Okay, so ultimately what I'm hoping is that you will start to see either you can compare just the formulas, or we can come up with some generalizations we can make. So we're going to do one more problem, and then we're going to make some generalizations. Okay? And then we're going to see if we can answer the remaining questions by using our shortcuts. Okay, so one more. Okay, so the circle. Now here's what I need you to be careful about. We talked first about what happens if we change only one dimension, just the height on the triangle, or just the base. Was it the rectangle we did next? We did just the height, no, the diagonal. So when we just did one dimension change, what effect did it have on the area? Okay, so it did whatever we were multiplying by. It didn't necessarily double or times 2. It depended on what we were multiplying by. So the first time we multiplied by 6, it changed the area by 6. Or when we multiplied the diagonal by 1/3, it changed the area by 1/3. Okay, that was one dimension. Then we looked at the next problem and it changed both dimensions. When we changed both dimensions, what effect did it have on the perimeter? Okay, so it was the same effect on the perimeter. So if we multiplied it by 2, the perimeter was multiplied by 2. But what effect did it have on the area? Okay, be careful because it's not going to just be double whatever it was. So let's see. So here's where it gets kind of tricky is when you get to things like a circle or an equilateral triangle, because in those two formulas, there's only one variable. What's the formula for area of a circle? Pi r squared. And what's the formula for circumference? 2 pi r. So there's only one variable. But when you change the radius of a circle, you're changing the radius in all directions. So it's really changing all the dimensions, right? And the same would go for an equilateral triangle. If you change the side length, it's not just changing one dimension on the triangle, it's changing every side length because they're all the same, which is ultimately changing all the dimensions. Okay? So you have to be careful. The first two examples we did, make sure you're getting your head wrapped around this, we only changed one dimension, but each of those examples had 2 dimensions. It had a distinct base and a height. In both the triangle, and then when we went to the kite, it had a diagonal 1 and a diagonal 2. So it had 2 different dimensions. But then when we looked at the next problem, We changed both the base and the height on the rectangle, so we changed all the dimensions, right? So when we look at the circle, if we multiply just the radius by 1/5, it looks like we're only changing one dimension. But that is the only dimension that the circle has. Are you following me? So let's look at what happens and see if we can make a generalization. All right, so start with circumference. We'll do it the long way first. So the original radius is what? 10. So we have 2 times pi times 10. And we get what for our answer? 20 pi. Okay, now we're going to go and find the new circumference. Sorry, 20 pi. We're going to take the radius and what are we going to do to it? Multiply it by 1/5. So what is 10 times 1/5? 2 centimeters. So now our radius is only 2 centimeters. What's 2 times pi times 2, leaving it in terms of pi? 4 pi. Again, what goes on top when we're comparing these? The new. So we're doing the circumference of the new divided by the circumference of the old. So what number's on top? 4 pi divided by 20 pi. The pi's are just going to cancel out. And what are we left with? 1/5. So we changed one dimension, but because a circle only has one dimension, it goes in all directions. That radius changes everything. When we changed that one dimension, it had the same impact on the circumference because it really changed all the dimensions. Does that make sense? The same thing would happen if we were looking at the equilateral triangle. If we change just the side length, it's going to change all the side lengths. So it's going to change all the dimensions. So it's going to have the same impact on the perimeter. Okay? So we would say the circumference is multiplied by what? 1/5. Make sure you write a complete sentence. Then we will do it again for the area. So area of the old should be pi times, what's the radius? 10. And then we're going to square it. What's 10 squared? So we have 100 pi for our area of the original shape. The area of the new one, when we multiplied the radius by 1/5, we got 2, so that's going to be pi times 2 squared. What's 2 squared? 4, so we get 4 pi. And now we're going to do the area of the new divided by the area of the old. So that's 4 pi out of 100 pi. Pi's cancel, and we're left with 1/25. So our answer should be the area is multiplied by 1/25. So now let's see if we can make some generalizations, okay? So I'm going to write them over here on this board. If I were you, I would write these down, even though they may be sort of, I don't think it's all in your notes, but some of it is. I would still write this down, okay? So here's our generalizations. Hopefully we can get some shortcuts here. So if we change one dimension by a factor of A, only one dimension and there's multiple dimensions. Keep in mind, the special shapes like a circle or an equilateral triangle, when you change one dimension, it changes all the dimensions. But if you only change one dimension by a factor of A, so you multiplied one dimension by A, what impact did it have on the area? Okay, the area is multiplied by A. But keep in mind, that's if there's more than one dimension. So like a triangle, a rectangle, a regular polygon that's not made up of equilateral triangles. If you change one dimension and there's multiple dimensions, it's only going to multiply the area by A. Everybody agree with that? Okay? So now if you change all dimensions by a factor of A. Keep in mind, I would maybe make myself a note that there are special circumstances or special shapes. And those special shapes would be an equilateral triangle, because if you change one dimension, it changes all of them. The circle, because when you change that radius, it changes it in all directions. And what special regular polygon is made up of 6 equilateral triangles? The hexagon. So it's also going to be the same, because now if you change the side length on that hexagon, it changes the side length on every equilateral triangle, which means it changes all the dimensions. Does that make sense? But only if it's a regular hexagon. So these are your special shapes that when you change one dimension, changes all dimensions. If you changed all dimensions by a factor of A, what effect did it have on the perimeter? Okay, the perimeter was multiplied by A. Now here's the part I don't know if we've come to yet. Maybe it's starting to get in your head. What effect did it have on the area? Good. The area is multiplied by A squared. So if you think back to the first one we did, you guys said it doubled it, but that's because 2 squared is the same as 2 times 2. It really isn't doubled when you look at it in this one, right? So it's not a good one. That's why we did another one, and we talked about the circle, since it changes all the dimensions, because 1/5 squared is 1/25. So whatever you're multiplying by, if you multiply all the dimensions, it multiplies the area by that value squared. And so these are your shortcuts, which means you wouldn't have to do any of that work. You could simply read the question and say, I know the answer. The area is multiplied by whatever the number is, or the area is multiplied by that number squared. And you don't have to show me any work on your homework if you can use the shortcuts. Okay, if you get confused and you're not sure and you want to check it, go back, work them out, divide new by old, and check and see what is my answer. Is this making sense? Okay, let's try some problems again next. Come on. It's back on 10-6. I don't know what I do. Okay, so here's the chart in your notes, but it did not have what happens when you change only one dimension. So that you make sure that you've added the very first thing I wrote on the board over there. It only has what happens when you change all the dimensions. Okay, so here's one where let's see if we can work it. So it says the circle has a circumference of 32 pi inches. If the area is multiplied by 4, and what you think about your shortcuts here. First of all, we're dealing with a circle, which is one of our special shapes. If the area is multiplied by 4, what happened to the radius? So if the area is multiplied by 4, so what are they giving us when they say by 4? That's a squared, right? Because they're telling us what the area was multiplied by. So they're telling us a squared is equal to 4. So what is a equal to? A is equal to 2. So then if we read our chart going the other direction, that would mean that the perimeter would have been multiplied by what? 2. And the dimensions would have been multiplied by, which in this case is 2. So what the question says, what happened to the radius? And we would say the radius is multiplied by 2. Does that make sense? The radius is the dimension. So they told us we're going backwards now. The area is multiplied by 4. 4 is a squared. So a must be 2. So now we could say the perimeter is multiplied by 2 and the dimension was multiplied by 2. And in this case, the dimension is the radius. So the answer would be the radius is multiplied by Mm-hmm. Complete sentence. Questions before we go on, if I confused you there? Okay, let's try another one. Go to the next one. What shape do we have? All right, so is it our special or is it not? It's one of our special ones, so that means when you change one dimension, you're changing all the dimensions. So this time it says the equilateral triangle has a perimeter of 21 meters. Think about that. If the perimeter is 21 meters and it's equilateral, what's every side length? 7 meters. Okay? And this time it says if the area is multiplied by a half, what happens to the side length? So the area is multiplied by a half. So go back to your chart. This is our special one. If the area is multiplied by a half, so what are they giving me when they say by a half? A squared. So they're telling me 1/2 is equal to a squared. So what is a equal to? What do you do? Put your calculators away. What do you do to solve for a here? Take the square root. So if I take the square root, no calculator. Simplest radical form, it doesn't say it around anywhere. Square root of 1 over square root of 2, which simplifies to? Because what's the square root of 1, first of all? 1. So we have 1 over the square root of 2, and then I'm hearing you guys saying multiply by square root of 2 over square root of 2 because we have to rationalize. So this is just square root of 2 over 2. Okay, so they can get a little bit harder when they're not these nice pretty numbers like 4, 9, 16, and we have to take the square root. But you can do that. Just put the calculator away. Don't get so dependent on that calculator. So a is square root of 2 over 2. So now you could say, it didn't ask, but we could say the perimeter was multiplied by the square root of 2 over 2. So if it did ask us for the perimeter, we could answer that. And the dimension, so it says what happens to the side lengths, those would be the dimensions. So the side length is multiplied by square root of 2 over 2. Okay, so what, it's not asking for the side length, it just says what happens to the side length. So your answers are all going to be things like the side lengths were multiplied by, the area was multiplied by, the perimeter was multiplied by, whatever it's asking for, the effect of change. So you would just say the side length was multiplied by square root of 2 over 2. Does that make sense? All right. I hope it really did. This is the only